Hey everybody, this video is on section 6.6, analyzing graphs and quadratic functions. Make sure you take notes and answer the survey questions at the end of the video. Alright, so forms of quadratic functions. There are two forms of quadratic functions. First one is standard form, so y equals ax squared plus bx plus c. This is the one that we've talked about in class the most. The next one is vertex form, y equals a times the quantity x minus h squared plus k. This may look a little bit familiar. It looks like the absolute value equation that we talked about earlier this year. Vertex of the parabola is represented by hk, and the axis of symmetry is x equals h. Y equals x squared is a parent function of all quadratic functions. So all these different forms of equations come from y equals x squared. So let's look at these graphs. The graph to the right has the graphs of y equals x squared plus 2, and y equals the quantity x minus 3 squared. Okay, you can see that over here on the far left here. They're color coded, so red, blue, and green. Adding a constant to x squared moves the graph up, which is evidence of from going from our red graph to our blue graph. And subtracting a constant from x before it's squaring, so inside of the parentheses here in y equals x minus 3, is evidenced from, or it moves it to the right, is evidence from going from red to green. Okay. Each of the graphs can actually be written in vertex form. So here's a graph on a table on the side that kind of shows this relationship, where in the first one, our vertex is 0, 0, so both of the numbers h and k are 0. On the and then the next one, x plus 2, h is still 0, but k is 2. And then the last one where k is 0 this time, but h is 3. And notice it's minus h, so we get a positive 3. A translation slides a figure on the coordinate plane without actually changing the shape or size. If we have x minus h, it shifts to the right. If we have x plus h, it shifts to the left. Okay, so it's kind of counterintuitive, just like when it was with absolute values. If we have plus k, it shifts up, and if we have minus k, it shifts down, just like you would think. All right, so let's look at this example. Analyze y equals x plus 2 squared plus 1, then draw its graph. So what we're going to do here is we're going to find its vertex. Okay, and we're going to find its axis of symmetry. Okay, and then based on those two pieces of information, we're just going to make a quick graph. So we need a coordinate grid. Okay, so our vertex. So we're going to look. Remember, it's y equals a times x minus h squared plus 1. So let's start with our vertex. So right off the bat, remember on the inside. Oops. Sorry, this should be k. Remember on the inside, it's opposite. So since we have a plus 2 here, it's going to be a minus 2. So our x-coordinate is negative 2. And then we have k on the end, and it's the same sign. So here it's a positive 1. So we get a negative 2, positive 1. And we graph that on our coordinate grid. Then last, our axis of symmetry, real quick. We get x equals h, which in this case, h is negative 2. So our axis of symmetry goes through here. I'm sorry, my picture looks gross. Yours probably looks better since you're not doing it on a computer screen. Okay, and now we can kind of draw a picture here and get something nice. But I'm just gonna draw real quick. Parabola. Just those are the two pieces of information that are really the most important here. Okay. Now, how does A affect a parabola? So compare the graphs of the functions y equals 2x squared, y equals 1/2 x squared, y equals negative 2x, and y equals negative 2x squared. Y equals negative 1/2 x squared. Okay, so we have them over here on the right hand side this time, where we get each one is a different color. Okay, in the same order on the left. Okay, so take a look at those. All the graphs have the same vertex of 0, 0, and the axis of symmetry, x equals 0. Okay. Now, the graphs of y equals 2x squared and y equals 1/2 x squared, so notice 2 and 1/2, are dilations of the graph of y equals x squared, our parent function. Okay, so remember that we had translations, now we have dilations. Dilations are when we either have like a vertical stretch or what I call a vertical squish. Okay, so either it gets, a stretch is narrower, a squish is it gets wider. So the graph of y equals 2x squared is narrower than the graph of y equals x squared, while the graph of 1/2 x squared is wider. Okay, it's kind of backwards. So the bigger the a, the narrower the graph. The smaller the a, but as long as it's less than 1, so a fraction, the wider it is. Also, we get the graphs of y equals 2x squared and y equals negative 2x squared, and these are reflections of each other. Okay, so what happens there is it causes our picture to flip with a negative a. So when a is greater than 0 or positive, the graph opens up. If a is less than 0, so negative, the graph opens down, which we kind of already knew that from the previous form that we talked about in standard form. If the absolute value of a is greater than 1, so if the positive value of a is greater than 1, the graph is narrower than the graph of y equals x squared. And if it's less than 1, then it's wider. Okay, here are your survey questions. Make sure you answer these on your notes and have any questions ready for class. See you then.